Hi again. So now on to our third chapter, which is dynamics. So in the start, I'm just going to give you a brief overview of what dynamics is and how kinematics and dynamics are related. So dynamics is basically the branch of motion that deals with forces, right? This is the simplest definition. You'll be dealing with forces here. And kinematics is the branch of motion, right, or mechanics, which does not deal with forces. It's forces. So now, as you can guess, in dynamics, we are going to study forces, and these two together makes the branch of physics called mechanics, which is the branch in physics that deals with motion of objects. So let's begin. Now, the first thing you're going to need to know is what mass is basically. So, the mass is basically the amount of substance in a body, right? That's the most common definition that we know of. And that definition is fine as well. But in A levels, a more advanced definition is required of you. I mean, not required. You can write the other definition as well, that mass is the amount of substance in a body. But perhaps a better definition would be the ability of an object to resist change in motion, right? So this is perhaps the better definition. This is a modern definition of mass. And perhaps if you study a lot of physics, you'll know why this is the case. But right now, I'm not going into that. So the unit of mass, as you know, is kg, and it's a scalar quantity, right? Obviously, it's a scalar quantity. Now, on to a formula that you probably already know, which is the resultant force is equal to mass times acceleration, right? Mass of the object on which the force is being applied and acceleration of the object. So a requirement of this formula is the direction of acceleration and resultant force, right? Not all forces, but resultant force is same, right? So I'll show you what that means in these examples. So let's just do them. This is a common one, right? So let's just take right to be the positive direction again. So F2 10 minus 3. This is actually a plus, right? Even in this formula, this minus is assuming that the force is backwards, right? The force 2. But this could be a force like this. Actually, you know what? Let's just do it. Let's just do it like this. Let's just do it our own way, right? So the 3 Newton backwards is -3, right? And the mass of the object is 5 into a. So let's just find its acceleration real quick. 7 over 5 is this body's acceleration due to these forces. Now, what I'm talking about is basically you shouldn't view these forces as forward and backwards, right? They can be up and down, right? So let's just do this our own way, right? For example, there's a box of 2 kg and there's a force of 5 newtons here and 3 newtons here, right? So instinctively, you know that the resultant force is 8 newtons, right, to the right direction. But you don't have to basically subtract anything, right? So write the formula, understand the formula in this way, that you're adding all the forces. And it just happens to be the case that this force was negative because it was in the negative direction as we took. And this one, in this case, both the forces were in positive directions, right? So directions is basically very important when it comes to vectors, right? Now, on to a more complex problem, which is this one. So first, we don't know what this force is, right? We can't register this force in our system. This force is nothing to us, only its components. So this component is 10 cos 30, which is 5 under root 3, or let's just take it 8.7 newtons. And this component right here is 5 Newton. So this is our force. This force is expressed in these two components. You know this concept very well from the previous chapter. Now, there's a resultant force in two directions, right? There's a right force in the horizontal axis and in the vertical axis, right? So let's just take the horizontal axis first. So 8.7 is equal to 3 times A, right? But that is not the resultant force, right? So we can't do this. So let's just do it with our method of summation x is equal to 8.7 and summation y is 5 plus -3, which is 2 Newton, right? So our resultant force would be this 2 Newtons, 8.7 Newtons, right? These two are the components of our resultant force, and our resultant force would be 8.9 Newtons, on average, rounding off 8.9 Newtons, and its direction would be, let's just do tan theta. So theta is equal to tan inverse 8.7 over 2. So 77 degrees. Theta is equal to 77 degrees, right? So this is basically our resultant force, right? 77 degrees and 8.9 Newtons, right? So this resultant force of this system is this, right? So what we do now is just apply this. Mass is 3 kg into acceleration, and this comes down to, right, 2.97. Acceleration is 2.97 meter per second square. So this is our acceleration and this is our resultant force. Now, if you have to guess the direction of the acceleration, what would you say would be the direction of the acceleration? I would say that it's at 77 degrees above the horizontal axis or the positive x-axis, right? This suffice in this case. This is just enough. So because the force and acceleration must be in the same direction, so this is where the box will accelerate as well, and this is where the result force will be applied. So this is a pretty complex question. Just included in here so you can understand this concept of direction even better, right? Now moving on to the basic concept of momentum. We'll go into momentum a little bit later in this course. So right now, just need to understand that momentum is product of mass and velocity of an object, right? So for example, this is a particle with a mass of 3 kg and the velocity of 2 meter per second. So its momentum would be 3 into 2, which is 6, right? 6 kg meter second, right? So this is the unit of momentum. No derived quantity right now, just understand the basic units. And now on to weight. So weight is, most of you guys probably know this, the product of mass into acceleration due to gravity, right? So the difference between mass and weight basically is that your mass will always be constant, but your weight can differ based on gravity, right? So you would weigh less on Mars, for example, or Moon, for example, but your mass would be the same, right? So the unit of weight is in Newton because it's a force. So it's in Newton. Or the base units is kg meter per second square, which is force, right? Now, on to the most important concept of this module, which is the Newton's laws of motion. So the first law is the same as the law, what you have studied in your O levels or 10th grade or whatever, which is a body retains its state of motion until a force acts on it, right? So for example, if a box is sitting here, it will keep sitting here until you push it. Or if a box is moving, right? If, for example, a ball is moving through the air, it only stops because there is the force of drag or wind resistance, right? That stops it. Otherwise, it would keep going on and on, right? Now, the second law is a little bit changed, which is force is equal to change in momentum per unit time, right? So how much the however much the momentum has changed in however much time, right? That is the force. And we can basically show this as well from the original formula, which is ma, right? So ma becomes, acceleration is velocity over time, right? Delta velocity over time, right? So mv is momentum, right? So this becomes delta momentum over delta time, or change in momentum over change in time, right? So everything remains same. The unit is still the same as everything. Just you always have to write this law like change in this form now, which is change in momentum per unit time. Now, do keep in mind that these are all marked scheme definitions. So if you memorize these, it's good for you. Now, third law. Now, the third law suggests that if an object A exerts a force on object B, the object B will exert a force on A, which is of the same magnitude, right? Same magnitude. These are the keywords: same magnitude, same nature, but in the opposite direction, right? So you already know the concept of this, but let me just share one example with you. So for example, this is a table, right? And there's a book resting on the table, right? And the force of its weight is basically 10 newtons. Now, and the force that the bench is applying onto it, right, is 10 newtons as well. So you might think that this is the third law of Newton, third law of motion, but it's actually not true. This weight is a complementary force to Earth's gravitational field, right, which is being applied on the Earth as well from the box. And this force is the complementary force of the 10 contact force of 10 newtons, right? So this is something that you have to keep in mind, that the nature, magnitude, and direction remains as stated in the third law of motion, right? So this was just a short example. If you don't understand it right now, don't worry about it, because we're going to go through all of these nuances in our past paper practice. So right now, I just want you to memorize these laws and just understand the concepts, these basic concepts of things. And I'll see you in the next module. Thanks for watching, and subscribe to the channel. Goodbye.